There's lecture today. I'm just looking at things and getting it set up. Hey, I got a minute left. Hey, hold on. I'm just getting IntelliJ set up with the clicker starter code. No lecture Monday is what I was saying, if that's what you heard. No lecture next Monday. Next week, no 116 anything. Some of the TAs are still hosting office hours, but I'm not requiring them to. But if on their own volition they still want office hours, they can do that. If you get an F, you fail in life. That's game over. If you fail this course, you will die. Watch my viewers go up. The deadline for all lecture questions is December 11th. Yes, that is correct. December 11th at midnight, that's when all of the lecture questions shut off. So those of you who are way behind on lecture questions, that's only 3 weeks away, so get on it. Those of you still doing lecture questions from Learning Objective 1, in my opinion, you don't have enough time. If you really 100% understand everything in the course and you just haven't felt like doing lecture questions yet, yeah, maybe. But if you're already struggling to get those lecture questions done, if you've been trying, you don't have enough time. If you're struggling with LO1 lecture questions, you're not going to be able to get the rest of them in 3 weeks. Maybe if you make 116 your whole life for 3 solid weeks, but even then, it's tough. All lecture questions done. Congrats, P. No lectures next week. Yep. Pan some Susum. Good to have you back. Glad to hear you're feeling better. What is it? November 20. What's up, Trino? For expansion interviews, I'll get the logistics out sometime over break. I'll post on Piazza. I'll have a Google form where you can submit any expansion objectives you have done. I'm not sure how the interviews are going to work for that yet, but we'll get something set up. Because those interviews will be quicker than regular homework interviews, so we can schedule like even 5-minute time slots or something. I don't know how it's going to work yet. I might even have just a big block of time where I have open time where you can just come in and show off your extensions. Just haven't figured out the logistics yet that I want to go with. Consequences failing 116 is death. Would I get more students to pass? Is it ethical? Find out next time. Yeah, only 3 weeks left and only 2 weeks of actual classes. We're at the end of this crazy, awful semester. Next job is group project. It's not really a group project. I'll of course talk about this when we come back from break. I'll have all the logistics ready. But for the project contribution, the whole class is one big group effectively, and your only objective is to create a pull request on a repository that I have. To be honest, I want to do more with it, but in its current state and the state that I'm going to release it, it's basically a free application objective. Don't miss that one. It's super easy. I'll give a tutorial and lecture. You follow the tutorial, create the pull request. Done. If anyone misses that application objective, I know you didn't really try. So the last lecture question of the semester is to write a WebSocket server for direct messages. What's up, mbud? Xmbud. Direct messages. So write a DM server class that is a WebSocket server that listens for messages of type register with someone's username and registers that user. And by that I mean adds them to some type of data structure or data structures where you're remembering this username belongs to this socket that sent this register message. So you have to be able to remember that name. And then responds to messages of type direct message, which is a JSON string containing a username, who I'm sending this message to, and the message that I want to send to that person. When you receive a direct message, a message of type direct message, you have to send a message over the socket associated with this username. So you have to look up in your data structures and see, okay, which WebSocket is associated with this username. Find that WebSocket and send to that WebSocket a message of type DM, where the from is the username of the message of this socket who sent you the direct message. So whatever the username that socket registered with, and the text verbatim that they told you to send to them. So this is your last lecture question. Here's some example functionality. And we saw the chat app on Wednesday, so your goal is to add DMs to that. And there are a few things not defined here. For example, sending a direct message to a user that doesn't exist, or receiving a direct message from a user who has not registered. You can assume that everybody's using this in the proper way, that anybody who's sending a direct message has already registered, and they're sending a message to a user who has also registered. So you can assume that all these usernames are in your databases. That's the way I'm going to test it. I'm going to test this with just proper usage. You don't have to do any error checking for this one. So if you're tempted to write all the error checking of saying if this user in the database, you can still do that if you want. It ain't going to hurt anything. But my test is not going to test your any broken functionality, any improper use of the server. Do I teach any other courses? I teach 312 each spring on a regular basis. And then on and off some different courses. Like I'm teaching 442 this semester, as I'm sure you know. But that's probably not going to be a regular thing. I used to teach 442 regular, and I've been getting off of it lately. Register, how to listen to, I think every example I've shown listens to multiple different message types. What you do is add multiple different listeners to your server. So I think we did with the chat app. Let me see if I can. No, I can't do it real quick because I have the clicker code loaded up. And I don't like having two IntelliJ projects loaded up at the same time while I'm streaming, because I have what happened that other time where I'm putting one IntelliJ on stream, but I'm showing examples from the other one, and y'all can't see what I'm doing. So to avoid that, I only open one at a time now. But they do react different, but you need to have two different listeners. Register, which listens for a string message, and direct message, which listens for a string message. So you add two different listeners to your server, and then react to those different messages differently. Is there a new CSE 116 prof next year? So it's so we have two instructors for 116, so I'll have half of the class, and she'll have the other half. Okay, so let's talk about the clicker architecture. So you should be starting on your clicker assignment. You have everything you need to be able to complete the clicker assignment at this point, of course, because we're at the end of the learning objective. So it's time to be working on that. You do have, just because we have break, you do end up having 2 weeks to work on this. But if you're assuming you're working over break, but there's not a lot of room for extensions. So if you're the type of person who likes to try to bank off the extensions, just know that we're running up against the end of the semester. I can't give you much of an extension. The extension's only going to be 1 week if you do get the extension. I'm not going to have something due during finals week. So it'll be due along with everything else, and you'll be busy enough doing expansions and everything. Effectively, there's not going to be an extension on this. There will be that 1 week extension, but since you're doing project contribution at that time, you're doing expansion objectives at that time, you're wrapping up any lecture questions that you might have to do at that time. You're going to be doing a lot of extra stuff. You're not going to have time to make up a homework that you weren't able to complete in 2 weeks. That 50% extension of the deadline probably isn't going to help you in this case. So there will be that 1 week extension, but just be aware that deadline is effectively more of a hard deadline just because of the logistics of what you'll have going on. I'm sure all your other classes will be crushing you at that time too. You're not going to be able to take advantage of that extra week very well. So just be aware of that. But with that, let's set up what this assignment is even doing. Let's walk through the architecture and the way the messages are passed. and get this done, preferably over break. Get it done by Monday even. Get one thing off your plate that you don't have to worry about anymore. How many expansion interview chances do we have? More than one, right? You really shouldn't be failing an expansion interview. So expansion interviews aren't the same as homework interviews, where we're not grilling you on like the code you wrote. As long as you demo your expansion functionality, we usually count that as good. I mean, if we might ask some more questions, but nobody should be failing an expansion interview. If you did the expansion objective, there shouldn't really be a way for you to fail. Of course, I would say the same thing about a homework. If you did the homework, you shouldn't be able to fail the homework interview. If you actually did the homework, there's nothing to worry about. And we've had very few students actually fail a homework interview after getting credit in Autolab, actually having the code finished. So I wouldn't even worry about it. But I suppose if there was some legitimate reason why you didn't get the expansion interview, then yeah, maybe you just came to the interview without finishing it and tried to squeeze your way into a grade that you don't deserve. I'm probably not going to give you a makeup opportunity, because why did you just waste both of our times? No, you can't schedule them yet. I don't have the logistics up for that yet. That's something I'll be getting over break. That and the project contribution logistics. I'll get that out over break, and we'll be ready when we come back the following Monday. We'll have everything that you need. All right, so Clicker architecture. This is at a high level what the architecture is for the Clicker assignment. We have a chat server, which is a WebSocket. That says chat server. Oh my goodness, this isn't a good start. I missed that one. So this should be Clicker server, which is a WebSocket server that's going to both create and connect to an actor system, and connect to clients that are going to register with this server. So at a very high level, we have a WebSocket server, we have an actor system, and we have communication between the two, and also communication between clients, where this dotted line, is going to represent the internet. We could connect over the internet like you do if you go to clicker.cse-software.com. That's connecting over the internet your client using my web front end, connecting to my Clicker server, which is running on my server, which is maintaining an actor system. So let's walk through this one step at a time, and I'll go in order chronologically. What happens when you start up a Clicker server? And I'm going to... Did I do that on the last one? I'm going to put this kind of on that dotted line to show that this Clicker server is both part of the internet connection and part of this actor system. So the Clicker server is an actor and maintains the actor system, and also communicates with the outside world. So it has a foot in both worlds over here, over in the internet world, and a foot in this actor system. That's not a typo. I meant to put that on the line, by the way. So we fire up the server, and the server is going to start listening on port 8080, of course, listening for WebSocket connections, just like we did all this week. And it's also going to create an actor system. This is where we're finally combining the content from last week and the content from this week. So we fire up the server, and if you look at the server code, you'll see that it's receiving an update games message at regular intervals. I'll talk a bit more about that in a later slide. And it also creates an actor system, but doesn't add anything to the system quite yet. It's going to maintain the actor system, but there's nothing to add to it yet. Once a client connects to the system, just like what we did with Chat App, and just like what you're doing with your DM server, the DM server is, by the way, designed to help you maintain these usernames in the Clicker assignment, is a client connects. We don't do anything with the connect event. We wait for the client to send a start game event. Just like for your lecture question, you're not doing anything with the connect event. You're waiting for them to send a register. Let me just double check. You're waiting for them to send the register message where they're registering their username. Just like what we did with the Chat App as well. They had to register their username, but we don't do anything with the connect event. So we're doing the same thing here. And P, no, you don't have to check if the username is already in use. So that's something we could add if I wanted to bloat up the assignment and make it a little more challenging. I would have you check the usernames, but we're going to allow that. Like if you go to if you go to my deployed one at clickerccesoftware.com, if you go to that one and open up two tabs and input the same username in both tabs, you're going to get some wonky behavior because my server's just going to be like, yeah, that's fine, you can do that. But it's going to overwrite the second one. It's going to overwrite that username and that actor, overwrite the first one with the second one. It's going to be awkward. I'm not going to test multiple instances of the same username. That's not something you have to worry about with this assignment. So a client is going to send a message of start game, which is going to contain their username. They're going to say, hey, start a game with this username. This is me. Remember me when I send messages. This is the username associated with that message. I think we can add, you can add that. If you want that to be the functionality, you can. Since I'm not going to test it, whether you have that functionality or not, it's not going to affect your grade. But if you want to add that functionality that you can't reuse the same username, if the username is already in use, maybe you want to send the client, they send start game with this username, and you want to respond with that username is already in use, try another username, you can add that functionality. That's not going to hurt the grader, since I never checked for duplicate. I never test with duplicate usernames like that. So you can add that if you want. It's a nice feature to have. It's something I should add. I shouldn't say should. I could add to the deployed server. I won't because the point of having a deployed one like that is so you can test the functionality. If you are wondering what should my app do in this certain situation, you can go to that page, do that specific thing, and if mine breaks, then you know that that's not something you have to do, not something you have to address. So I won't add it to that, but maybe next semester I'll add it to the assignment. I don't know, who knows. So the client sends a message of type start game containing their username, and when the clicker server receives that message, it's going to access the actor system, create a new actor of type game actor, add it to the system, and tell that game actor, the game actor constructor takes a username and a configuration string. So the game actor that it creates, it's going to tell it, hey, this username, this configuration string, fire up and start listening to messages for this client and start, being a clicker game. And I actually forgot to mention the configuration earlier. When we start up the server, we're going to give it a configuration, which is a big old JSON string with all of the configuration of the game, what buildings are available, how much they cost initially, how much their price increases for each one that you purchase, how much they contribute to how much they contribute per click, and how much they contribute per second. All that is going to be in one big JSON configuration string. So that string, the clicker server doesn't itself do anything with that string, but it does have to remember that string that it receives when it's started up, because every game actor that it creates, it's going to send that game actor a copy of that configuration string, and the game actor is going to parse that string and set everything up in the proper way, be expecting those buildings that can be purchased at those prices, etc., how much they contribute. And the game actor, this is what's going to control everything with the clicker game itself. And this is where I recommend starting the assignment. Write this game actor as a class that a game actor class that extends actor, that takes that username and configuration and controls the entire game. It receives messages. It'll receive various messages. Click, buy equipment, update. I think that's it. Just those three messages. It'll receive those three messages, react to those three messages, and do what it needs to do on those three messages. So we start the game actor. That's going to control the game, and we have a separation of concerns here. Game actor controls the game, and that's it. It doesn't know that it's part of a WebSocket system, and the WebSocket system doesn't really care how the game itself works. This is just going to control the inputs from the user and get the outputs from the game actor and forward them to the appropriate user. The clicker server doesn't have any game logic, and the game actor doesn't have any networking logic. So we're separating these concerns and doing these separately. This is a very important concept in programming, that we separate these concerns, or what we usually call it is encapsulation. The game functionality is encapsulated in this file, in this code, and we just expose an interface, which is you can click, you can buy equipment, you can tell me to update, and that's it. Everything else is completely independent. And then the clicker server just accesses that API by sending messages over the actor system of the appropriate types based on whatever whatever the client is trying to do. Clicker sounding less spooky now. Good. That's the goal of this whole lecture, is to get Clicker to sound less spooky. In my opinion, as long as you're following the content from this learning objective pretty well, in my opinion, it's actually the JSON stuff that gives students the most trouble, that can be the trickiest part of this. You have to parse a lot of JSON, you have to write a lot of JSON. And we only had one lecture question on JSON, and it was way back when. So remembering how to do JSON and then using it in a much more advanced application than the lecture question that we already saw. So that gets tricky. Remembering and recalling all that information. Yeah, I struggle with JSON still, Mango Mutiny. Because I don't do much with JSON earlier. I show you how to do it. I'm like, just do it. It's not too bad. But it does get tricky when you have more complicated applications. The JSON slides might not have explicitly everything you need, but it does show you what you need. And what I'd recommend is going right to that JSON play library, go into their documentation, and figuring out what to do after that. The slides do have everything you need if you do things in a particular way, in the way that I showed. But if that's not quite your coding style, you're going to have to read some documentation. So we're going to create a new actor. We get the register message. We get the start game message. We're going to create that game actor, update our data structures to make sure that we remember that this game actor that we created is associated with this socket connection for this client. So these are the data structures that we need to remember, because the client is never going to tell us its username again. Every message that they send hereafter is going to be a click message or a buy message. They're either clicking or they're buying equipment. Those are the two messages that we're going to receive, and neither are going to contain the client's username. So when we receive those messages, I'm getting ahead of my slides here, but when we receive those messages, we have to look up in these data structures that we're maintaining to know which game actor to send those messages to. And when a game actor sends the state to the clicker server, we have to remember which WebSocket to send that game state to. So we need to maintain these data structures that go from WebSocket connection to game actor and game actor to WebSocket connection. So when we receive messages from one, we know where to forward it. We know the associated entity to forward that to. To create these new game actors, we have our actor system created, but that's in the clicker server. But we have to add actors to the system through the event listeners that we're creating. So we're a little bit removed from the clicker server. And this is where what I've recommended in the chat app and on Monday as well, is that we have our listeners have a constructor that takes a clicker server as at least one of its parameters, possibly the only parameter. So in our listeners, if we have access to the clicker server, then we have access to, as an actor reference, then we have access to its context, and we can add new actors to the system through the context of any actor that's already in the system. And we saw this on... when did we see this? Did we see that on Wednesday? No, we saw it last Friday on the traffic example, where we had, in the slides at least, where we scheduled an event message to be sent later. We use some similar syntax to be able to add actors to the system after the system has already been set up. Yeah, so So every event from the client is sent to an actor for that client. That's gonna, yeah, we're absolutely async. We're concurrent. This learning objective I actually used to call concurrency because that's the main theme of it. But I ended up rebranding it as event-based architectures. But we're talking about the same thing, concurrency or event-based architectures. This idea that multiple things can be happening at the multiple time, like the concept of time kind of, I don't know, it's both more apparent but less relevant. I don't know, it's weird, but a lot of things can be happening at the same time. We don't really care when things are happening. I don't know, but we do. I don't know. There's not a good way to explain. I don't know where I'm going with that sentence. But the point is that we don't have code that's just running sequentially. This line executes, then this line, then this line, then this line, then this line. That's not what's happening anymore. We're saying when this event occurs, run this code. And events can be occurring all over the place in different parts of your program. The game actor might be updating at the same time that a user is clicking a button, and the clicker server might be processing something at the same time. We don't know. We don't care. All these things can be happening. But we do know that our code, we have certain pieces of chunks of code that need to be executed when certain events occur, whether those events are a connection, receiving a WebSocket message, receiving an actor message, whatever is triggering some code to happen. There's a trigger, which is an event, which in our case is almost always receiving messages. And then our code runs based on whatever message type we received, which is certainly async, which is all asynchronous. So this isn't very interesting, to be honest. Where it gets interesting is this: when we have multiple clients connected to the same server, and that server is maintaining these connections between clients, multiple clients, and multiple game actors, where each game actor is associated with a single client. So now this is where our data structures really come in. With just one client, who cares? We don't need data structures. With multiple clients, now it's important that we know if I receive a message from this client, I have to forward that message to the appropriate game actor to be able to get that update to be correct, to get the right game. We don't want this client clicking and then get it sent to the game actor for this client and then have that update show over here, and now this client got a click that they didn't do. This client's missing their click. We don't want that kind of stuff happening. So we can maintain multiple connections at the same time, and we remember these connections by storing references to the actors, references to the sockets, all in data structures, and keeping all those associations proper, keeping those associations the way we expect them to be. Yeah, and so this is why servers, I'll twist that a little bit and say this is why servers can take advantage of multiple cores. So multiple cores is kind of a reality of life these days. That if you buy a computer today, it's going to be multi-core more likely than not. With concurrent code, that's why this is a topic that we teach you in second semester. Since multiple cores are a fact of life these days, let's write code that's able to take advantage of all of those cores. If we don't have concurrency and we don't have event-based architectures or any of this, we're only able to take advantage of one core at a time. So if you have a GPU with thousands of cores, you can't take advantage of that running sequential programs. But if you have an actor system and a clicker, a WebSocket server set up like this, you can take advantage of every core. You can have 1,000 cores, you can have 1,000 people connected and all processing things concurrently, which is nice. Especially as it seems like we're only going to have more and more cores moving in the future. That's how processors are getting faster. They're not getting any faster objectively. They're just getting more cores. So let's take advantage of all those cores. That's what pushed this to be a second semester topic, where this used to be like a senior or a you never learn topic in college. Multi-cores, GPUs with thousands of cores, or however many they're up to now. Is it really up to millions? 10 million cores? And you don't need one core per user for Clicker, but more cores helps. This lecture is hardcore. Ooh, yeah. This one isn't too bad. And I'll even give you a break. I'll interact with chat so you can digest a little. If we have a competition and have all clients go against each other, we could. Maybe next semester I'll do that to the students. I'll force them to build that in the homework assignment. Actually, that would be a good expansion objective, to have a leaderboard, have a separate page that you can go to for a leaderboard. Be down with that. Maybe next time. All right. Oops, I didn't talk about this slide yet. So when one of these clients sends a click event, for what it's worth, the WebSocket click message of type click is a lowercase c that's not a typo. And then the actor case object is a capital C that's an object of type click, capital C. We're going to send that to the actor. So when a client sends us a message of type click over the WebSocket, we're going to look up our data structures, find out which game actor is associated with this WebSocket connection, and then send a click message to the appropriate game actor. And we'll do the same thing with buy. If this client is buying equipment, we're going to forward that to the appropriate game actor. And the game actor will check, can you afford this equipment? If yes, purchase this equipment, decrement their funds, increment their equipment of that owned by 1, and increase the price of that equipment for the next purchase. Process all that. When a click or a purchase is processed, the client does not get feedback on what happened with that click. The game actor receives this click, processes it, and doesn't give feedback on that. So the game actor, when it processes a click, it doesn't say, there's nothing that says, then respond to the sender with the updated state for after that click. So just be aware of that. There's no immediate feedback on an event like this. The game actor processes and then keeps that to themselves. So how does the client ever find out what happened with that click? Well, that's where this update games message comes in. So this update games message is going to be sent to the clicker server at regular intervals. When the clicker server receives that, it's going to send an update message to every game actor. That's going to tell the game actor to update its income per second and then respond with the game state. So the game state is only being sent, the game actor is only giving up information after, in response to an update message being sent. So when it receives an update message, it's going to respond, update, and then respond with the updated game state, which contains all the equipment owned, the income per second since the last update, etc. All of that information in a big JSON string in a very particular format, which is outlined in the doc, which we'll go to next. So we send this game state back to the clicker server. The clicker server is going to forward that game state for each game actor to the appropriate client. So the clicker server, and we can really see some concurrency here, it's going to get all these game states at roughly the same time. And for each one, it's going to respond by looking up the data structure, finding out which client that is associated with, and then sending that game state to each appropriate client over that WebSocket connection. So the clicker server, its main job is to be a liaison and to be able to facilitate communication between the clients and the game actors and kind of bridge the gap between WebSocket connections and actor messages being sent. So the clicker server's main job is to maintain those data structures and forward messages appropriately. The clicker server doesn't do much processing itself. Once the client receives a game state message, once a client receives the game state message, it's going to parse all that JSON and display it on the GUI for the user to see. That part, all the client code, by the way, is done for you. You don't have to do anything in the clients. You have a JavaScript file and an HTML file, which is going to run the client. It's going to connect to the server. It's going to have the buttons, the associated buttons and everything. You don't have to worry about the client at all. But the client that you have provided for you is going to parse that JSON string and display everything on the GUI. And feel free to judge the client up a bit. It's very plain right now. If you want to edit some HTML and make it prettier, if you want to have your own configuration file and build your own clicker game, I would strongly encourage you to do that. if you're interested in that at all. Make it your own. Make it nice. A few students have in the past. They shared some really nice looking clicker games. And this update games in the handout code, this is sent 10 times per second. So we have a 10 FPS, if you want to look at it that way, a 10 FPS game where every 10th of a second update games is sent to the clicker server. The update message is sent to the game actors. They respond with the game state, and the game state is sent to the clients. So the client, when they click or buy equipment, they don't get any immediate feedback from the game actor, but at most, they're waiting a 10th of a second to see plus network delays. They're waiting a 10th of a second plus network delays to be able to see that change occur. So that's why when you're using my deployed app, you're not really going to notice any delays unless the server is chugging along. Maybe a lot of people are running their auto clickers on it. Sometimes it bogs down. But under normal operation, you're not really going to notice that 10th of a second delay, and it's a 20th of a second on average. Plus network delays, so maybe it is more like a 10th. But a PC is capable of 0.001 FPS. Yeah, if your PC is that slow, especially running this JavaScript, yeah, you might have a longer delay. But and you can up this. You can change this if you want a 30 FPS clicker for whatever reason. Just change that in the code. But 10 FPS, it's fine for testing for our purposes. You're not really going to notice that. But don't put it too high. If you put it at like 1 second specifically, you're not going to see errors in fractions of a unit of income for that. So, and I want to talk just one slide about the expansion objective for those of you tackling the expansion. The expansion is to add an autosave feature. So like the one that I have deployed, of course, has the expansion built into it. It's already developed, where you can close your browser. I can restart the server even, and you can log in with the same username, and you'll still have your game there. It just saves automatically. You don't have to do anything. It's just a pure autosave feature at regular intervals. So if you're building this, you're going to need to pull in some MySQL, or I do allow file I/O for this if you don't want to bother with MySQL. Especially since I haven't really covered it in lecture. I'll talk about it when we come back from break, but even then I'll talk about it quite briefly. So if you want to do file I/O for this, that's fine. Save everyone's game to a file. And do this at regular intervals. So just like we have update games being sent every 10th of a second, you can send, there's no auto-grading for this, so whatever you want to call it. If you want to call it save games, whatever. But some save message, some auto-save message to the clicker server, which tells all the game actors to save, which has the game actors either save files for their game associated, maybe named with the username would be one way to do it, or send that JSON string with the game state and the username to a SQL database and store it that way, any way you want to do it. And then when a new client connects, even after a server restart, if they connect and they say start game with a particular username that is already stored in the database, then instead of just creating a brand new actor, you have to create an actor that loads that game from the database, gets all of the current state that they currently had, all their income, all their buildings that they purchased, load up all that state, then send the game state back to the client and have their game that they were using all loaded. And when you do this, they also have to earn any idle income that they had. So the income that they have has to reflect all of the income that they would have if they were playing the game that entire time. So they can't, so once they load the game, say they stop for a day, they close the thing, they come back 24 hours later, they have to have 24 hours of idle income once they come back. So if they're making, a million, 10,000 gold per hour, they should have 240,000 gold extra when they come back. And you can do that as a little bit of a hint. You don't have to keep computing that. Depending on how you set this up, it should be automatic getting that idle income. Because when you load the game and then you get the next update message, if you're storing the last time that the game was updated, and then your update method when you're calculating the income from any update, you're looking at the previous update time and the current time, subtracting and then adding that much idle income. So once you load, that load file should store the last update timestamp, and then next time you get the update, you'll just automatically get all that idle income based on the code that you already have existing. So the idle income isn't too tough, but you do have to make sure you're storing the last update in the database. Let's bring this back to the lecture question. So let's go to the doc. There are a few things in here that I want to highlight specifically. One, the configuration format. There are two, every time, but why does it keep telling me that? There are two JSON formats that I want to highlight here. One is the configuration for a game. So if I want a game, this is the original game. The first time I ran this assignment, this is what the configuration was, and they hard-coded to this one actually instead of making it flexible. This is going to be exactly in this format. It'll be a JSON object containing keys currency, which is a string which says what the currency is that we're accumulating here. So here we're earning gold. So if I click the big button on the GUI, it's going to say gold on it. And when I click it, I earn 1 gold. So that's just what the theme is. Most of this is for theming, but we get 1 gold. Then the other key is going to be equipment, which is a JSON array of JSON objects, where each object has the keys ID, which is the ID for this equipment that can be purchased. This is when somebody tries to purchase a piece of equipment, they're going to use its ID to be able to purchase that. So if somebody says purchase equipment or buy equipment, I forget what the message name is, I'll mention it when I get down there, and the ID is shovel with a lowercase s, that means they're trying to buy one of these. If it's excavator with a lowercase e, they're buying one of these. If it's mine with a lowercase m, they're trying to buy one of these. The next one is name. This is the name of that equipment, how it's going to be displayed on the GUI. So we might want the name to be something different than the ID. And like gold mine, we don't really want the space in the ID because that could break things in certain ways. So this is the name that's going to be displayed to the user on the front end. Income per click is going to be how much income this piece of equipment contributes per click that I make. Actually, let me pull it up. I should code that to. So that's going to be how much income that gives me per click. So if I click this with this configuration, so for example, this configuration is code configuration where the display is compile code, the currency that I'm getting, how much code have I compiled. And Autolab, if I want to buy one of those, I'm going to send Autolab over the socket, and the display is going to be submit to Autolab. So submit to Autolab is what's displayed to me, the user. I'm going to compile code. That button gives me 1 code per click. And once I buy a submit to Autolab, as long as I can afford it, I now own one of those. The cost increased, we'll talk about that in a second too. And since this gives me 1 income per click, now when I click, I'm going to earn 2 lines. Maybe I should call it lines of code compiled, whatever. But I get 2 units of code compiled per click. If I buy another one, I'm going to get 3 units of code compiled per click. So depending on how many I own, each one of these equipment owned is going to contribute 1 to my income per click. So I have 5 plus the 1, don't forget the 1 in the button. 5 plus the 1 in the button is going to give me 6 per click. And if I can't afford one of these, nothing should happen. Nothing happens with the buy message that's sent. Since I'm in here, something I usually don't show. I don't know how useful this will be. Maybe it will, maybe it won't. But if I go to the WebSocket connection, oh, come on. And I go to messages, I can actually see all the messages that are being sent back and forth. So when I do send a buy message, I can see that I'm sending buy and Autolab that ID string, not the a message of type buy containing the string Autolab. The ID, not the display text. I'm sending the ID for that. And you can see 10 times per second, I'm getting the entire game state in the string. If you want to see what game state your client's actually receiving, you go into the browser console network, go to the WebSocket connection messages, and you can see exactly what. You can copy this and paste it in IntelliJ somewhere where you can read it a little better and see exactly what's going on. It can help you with debugging your server. Where am I? So income per click, how much per click does this give me? Income per second, this is when you have the update messages being sent to the game actors. How much is each building of this type contributing per second? Shovels don't give you anything, which is important for your testing. So you have an equipment before you build income per second functionality. You can use shovels to test at least your base functionality with clicking is working and your cost is working. So initially a shovel cost me 10, and the price exponent, this means that each time I purchase a shovel, the next shovel is going to cost 5% more. So this initial cost multiplied by 1.05 for each shovel that I own. So for example, the Autolab, the price exponent is 2.0, meaning that every time I purchase one of those, the price is going to double, which we can see in the clicker. Each time we purchased one of these, the price was multiplied by 2. So if I buy another one of these, we're going to rip through all the powers of 2. It's going to be doubled each time. And other pieces of equipment are not as, don't increase as much. If I buy a print statement, that's going to increase by 1.5. So we multiply that by 1.5. It's a ripoff. Yeah, because submitting to Autolab is not, it's a painful way to write code. If that's how you're testing, you're going to have a bad time. Some of you are very aware of that. And the other state is the game state that we send from the WebSocket server to the clients, or rather the game actor is generating when it receives the update message. It's generating this JSON string and then sending it to the WebSocket server, which is sending it to the client. The format for this is the username that you're sending to, the current currency that they own. My GUI rounds this to the nearest whole number, but when you send it, you should have the decimal. You should have the exact value of their currency. You do need to track this as a double, even though it's displayed as a whole number. And an array with all the equipment containing the ID of that equipment, how many you own, and what the cost of the next of that unit is. I think that's all I want to talk about there, right? So let's see this in the code, in the handout code, and what you have set up for you. So first you have the game, which is going to take, that's the one thing I missed when I was going through the slides. I didn't read all the bullet points, so I missed this one. When a client connects, they're going to send their username in a message of type start game. The server is going to respond, which you'll have to do. Yeah, I didn't give you anything in the server, which you're going to have to do. But the server is going to respond with an initialize message with the exact game configuration that was given in the in the constructor of the server. Tripping over my words here, but the clicker server is going to receive a configuration string in its constructor, and whenever somebody connects, whenever somebody starts a new game, send them that configuration as is. You don't have to modify it at all. Send that as is in a message of type initialize, and then that's going to run my JavaScript code, which is going to set up all of the, that kind of ugly table and this gross code that's concatenating a bunch of HTML. We're going to build all this when we receive that message. So we're going to parse all that JSON, build this table that shows all the data to the user and sets up the buttons to be able to purchase equipment, and adds it to the GUI. And then we're going to update that each time we receive the game state. So all this is given to you. The HTML, not much going on in the HTML. Zero CSS. We're not going for looks here. And of course, all the JavaScript, which handles the WebSocket connection. Yeah, that's hard coding. It's not the prettiest way. This is not how you should do this. You should use something better than this. But this is something that works, and it's something you can understand with what you know right now. You can follow this and know exactly what's happening. If I use a fancy framework, you won't be able to follow it anymore. It would be more proper, but there are pros and cons. The game actor is going to take that username and configuration. When it starts up, this is a class just like any other class. So even though it is an actor, we're using it as an actor, don't forget all of your stuff that you can do with classes. So in here, you can do, parse the configuration. You can do all that stuff right here, because when a game actor is created, any code that's outside of all the methods is going to be executed when the constructor is called. So you have access to the configuration, the username, do whatever you need to do with those two pieces of information, which is parse the configuration, set up your game. And what I actually recommend here is creating another class here. Why is it not suggesting Scala? So what I recommend is setting up another class that only controls, oops, I don't want to add that to Git, that only controls the game. Have the game actor just be worried about actor stuff, and have the game only be worried about game stuff. So you can separate those concerns as well. Have the game just worry about the game and not even be aware that it's part of an actor system. And then have the game actor just kind of forward messages to it and worry about actor messages. You don't have to do that, but I really recommend separating those two. So you don't have one file, one chunk of code, one class with just tons of logic crammed in it. That can get really tough. I even recommend having, and I do in my solution anyway, so of course I recommend it, is having another class for equipment. Having equipment with a constructor that has its ID, its name, its initial cost, its cost increases, and maintain everything with that, including how to convert it into a JSON object. Can make the rest of your code look a lot cleaner and a lot easier to manage. So you have 3 message types that you can receive. I give you the message types. Please use the message types that I provide, or else Autolab won't like it. You can either get an update message, a click message, or a buy equipment message with the equipment ID. And you have to respond appropriately to each of those messages. When you receive the update message, this is the only time where a game actor is sending a message, and it's sending a message of type GameState with a JSON string containing that information in that format that we saw in the handout document. And then finally, the clicker server. This is our first class that we're going to see that's an actor and also a server. So it's going to be an actor through inheritance, and it's going to set up a server, and it's going to have a reference to its server. So all the code we've seen for actors and all the code we've seen for socket servers, we have to throw them all in a single class. So we're going to set up the server, tell it to start. You'll need to add the listeners to this server to listen to the messages that the client sends, the start game, the click, the buy equipment messages. And if you want, it's kind of optional for the assignment, but you should have it for proper functionality, a disconnect message as well that's going to remove that that client from your data structures. So the startup code is here for you. You have to add the listeners and create listener classes, which are going to react to those message types. And since this is an actor, we need a receive method, which is going to react to the appropriate actor message types, which is going to be that game state that the server, the game actors are going to send to us. Post stop, you don't really have to use. It just means when this actor stops, also stop the server. It helps with debugging, so you're not always waiting for the port to be cleaned up. And then setting up the system. Like I said several times in lecture, I set up the duration stuff for you. The only exception is if you're doing the expansion and autosave, you do have to add another one of these to send an autosave message to the clients. But here's where we set our FPS. If we want 60 FPS, just lower your milliseconds. But we're sending update games to the server every 100 milliseconds right now. And reading code configuration. So if I run this server, I think that's everything I need to get out there. So let's call that the official end of lecture. And let me show you just a little extra. So if I run this clicker server, oh no, you know what? I can't even show you extra because this isn't my solution. This is the handout. It's of course not gonna do anything. Yeah, time for homework. Let's go. Oh, homework demo. I've demoed the homework already, but I'll do it again. Or do you mean you have an interview for a homework demo? But yeah, here's the homework demo. You can all play my demo. And then once we get up to the idle income, we'll see that once I purchase this, we'll be getting 50 income per second. And you'll be able to see this increment in fives. Since it's updating every 100 milliseconds, we're going to see this increment in fives because we're getting 5 per update. And it's just the way it happens. If we watch this long enough, we'll probably see something that's not a 0 or 5 in the ones place. Because I am tracking... Oh, I closed it. If you go to the network tab, you do have to refresh, by the way. Go to the WebSocket. I don't know why that doesn't open when I click. I have to click one of the other ones. But if I see my currency, it's not exactly, it's not exact. I'm just rounding it for display. But you do have to track the exact values using doubles. You can't do rounding on the server when you do updates because you'll lose information. In the last, did I talk about last update? I don't know if I talked about that at all. We should talk about that. So somewhere in your game actor, you're going to have to update really, I should just do clicker._. So somewhere you're going to have to update. So it helps to have... We did timestamp somewhere. I don't remember where I showed it during lecture, though. So you have some timestamp. I think I did it way back in Physics Engine when I used that as a lecture example to update velocities and locations and stuff. But if you store a timestamp, I like nano time. You can get the current time as a Unix timestamp by calling system.nanotime. So if I We have enough set up here, right? So I'm receiving the update games message. Cancel that log, wrong language. If I print out the system.nanotime every time I receive update games and start this server, we'll be able to see what this is actually giving me. And it's giving me, get ready for this one, the number of nanoseconds that have passed since January 1st at midnight in 1980. So how many nanoseconds have passed since that exact time on the prime meridian? Is that what it's called? But there's an exact moment in time, and it's telling me how many nanoseconds have passed since that moment in time. So with this number, the number itself doesn't tell us too much useful information. 1970, sorry. January 1st, 1970, midnight. This number itself doesn't tell us much, but when we compare two numbers, that is going to tell, it does tell us a lot, but nothing we're concerned about too much right here. So nanoseconds, we should be able to ignore the last, not ignore, but the last 9 digits. So if we ignore the last 9 digits, this is going to be the seconds place. So this many seconds have passed since that point in time. And if we compare two of these, if I have this value and I subtract this value from it, we're going to get roughly 0.1 second. We're going to be able to tell exactly how much time has elapsed. So if I start the game, if I start a clicker game, and as I initialize everything, I remember this timestamp, and these values overflow ints, by the way, so you have to use long to store these. When I start the game, I'm gonna note the time, the exact time when the game was started, and then each time I receive an update message, I can say how much time has passed since I started. And since it's nanoseconds, if I want these seconds, is that right? Is that enough zeros? I think that's the right number of zeros, right? Should be 9 zeros. This is going to give me the number of seconds that have elapsed from now since that startup time. And then if I update this timestamp each time I receive the update message, after I update, then I can start computing the amount of time that's elapsed since the last update message was received, since the last update was processed. So it's important to update this timestamp as well to make sure that you're always getting, that you're not always comparing this to when it was started up. So for example, if I keep this timestamp recorded and never update it and just say, this is how much time we've updated, okay, we're going to start the game. Maybe we get the update message in 10 seconds. We're going to get 10 seconds worth of income. And then in 10 seconds, we get track income again. We compute income again. Well, if we don't update timestamp, we're going to compute 20 seconds worth of income. So now we're going to have, after 20 seconds elapsed, 30 seconds of total income, which is not what we want. We want 10 seconds and then 10 seconds again. So you have to update your timestamp. It's a mistake I see a lot. I see it every year. Make sure you're updating your timestamp after each update. Let's go UTC. That's what I was trying to think of. UTC plus 0 without locale. So when I go through that, it seems like a lot, doesn't it? It seems like a lot. What I actually ask you to code in this, I don't think it's too much. I think it is reasonable, or at least in line with the other assignments. With Maze Solver being an exception. I think Maze Solver was a little easier. But if you go through what I recommend when you're tackling this, start with the game actor. Get your message types here. Case, click, case, by, type by equipment. Get your messages and just work on these one at a time. I would start with the update because, you guys start up here with parsing this configuration is the first thing you need to do. Parse the configuration. Then actually I would go with these two. I wouldn't go with update right away. I would go with click and by equipment. Test that with shovels, going through testing objective 1 in the testing opportunity 1 in the document. Implement click by equipment and parsing this configuration and get that functionality working. And then start working on your idle income with updates and writing the JSON string that's going to be sent back to the clicker server. And honestly, once you have that, most of it's there. The clicker server, you really have to understand WebSockets and actors and how they work. But once it comes time to actually writing the code, there's not a lot of code that you have to write in this file. It's creating your data structures to maintaining the connections between WebSocket clients, sockets, and actors. And most of everything else is forwarding messages. You listen for certain message types over the WebSockets and forward them to the appropriate actors, and receive messages from the actors and forward them to the appropriate WebSockets. And that's clicker. Time for 199 capture the flag. Good luck. It's fun. With that 199 activity, I have a lot of students who do it ahead of time. I don't know why. I see that for this one, but not any other activities. I have a lot of teams who show up and say, "Oh yeah, we already did it." So one of your teammates might have already done it, but I think it's fun. I'm biased, of course, but I think it's fun. You should do it anyway. Google Spreadsheets has their date starting at 1/1/1990 or 1900. I probably should know this, but I don't know how we represent dates before 1970. I'm sure that's why Google does that. But how do we track a point in time with a Unix timestamp that happened before the beginning of time? Like no one is there anyone here who was born before 1970? Are we actually sure that there was a universe before 1970? Because I don't have any evidence of that. Also, the Earth is flat. I didn't know if you know that. I can't. I held a straight face for longer than I thought I would during that. Because this one was fun. I like to think so. I'm happy to hear that. I ain't gonna complain. I ain't gonna argue against that. So fun that we can't wait till class to do it. Why would we use Unix timestamps? Because it's a way to communicate a point in time without having to worry about things like time zones, daylight savings, leap years, leap seconds, all kinds of that stuff. A Unix timestamp is just, there was this exact point in time. This is how much time has passed since then. Very simple, very straightforward. And then with that value, you can compute, okay, I'm in this time zone, so this is the actual date and time. You can get the date time from it. But the timestamp is very absolute. It's very cut and dry. And you don't have to worry about getting one timestamp on one side of daylight savings, one timestamp on the other side of daylight savings, and they don't sync up and all this crap. You don't have any issues with that. It's a number. I get this number, and I wait 1 second, and I know exactly how much that number is going to increase, no matter what. Time zones, I could be crossing time zones. It could be a leap year that I go into February 29th. I just don't care. It's just a number, and it's absolute. No worries, nothing with that. Or else imagine if you had to do this assignment, and I said, and you're testing it. Maybe I don't even say anything about that stuff, and I have it during daylight savings where we just put the clocks back, and you're debugging during that time, and everything breaks once we set the clocks back, and you're trying to figure out what happened. Why did everything absolutely break? It was just working a few minutes ago. We don't want to go through any of that. So Unix timestamps are there to save us. We are in the Matrix. So yeah, maybe the Matrix was developed in 1970. So this world that we're seeing, this simulation, didn't exist before 1970. Fun fact. Not many people know that. The Earth is only flat because spherical coordinates suck to code. I actually have a few assignments. I surprised I don't have one in 116 right now, but I've had a few assignments in the past in other classes where I have you getting lat and long and mapping them to a coordinate system, an XY coordinate system. Students hated it. I enjoyed it. I thought it was fun. Well, they didn't hate it. They hated it once it didn't work, and then they're just looking for anything to blame.